Okay, hi, good day everyone. Today we're going to be doing January 2023, number 9. Alright, so let's read it. X, W, X, and U are points on the circumference of the circle. W, X, and U. It's just to locate it to see what they're exactly telling you. TV, TV is a tangent to the circle at U. Just means it's touching the circle, right, at point U. UW is a diameter of a circle, and a triangle WXU is an isosceles, meaning two sides are equal, right? Now, from this, let us talk about what we know, right? First off, a triangle is 180 degrees, right? Next thing that we should know is that WU, which is your diameter, right? So the diameter, the angle opposite, the angle opposite your diameter in that triangle is equals to 90 degrees. Alright, so that means this angle here is a 90 degrees. That is one of your theories for circles, right? So if you have a triangle, right, and your triangle, one of the sides is a diameter, the angle opposite that diameter in your triangle is 90 degrees. Alright? Next thing you should know is that right. So I told you guys that triangle W U X is an isosceles. Well, I didn't say that, but the question said that. Alright. We also know that if it's an isosceles, two sides are equal and the base angles of those two sides are also equal. Right? What I mean by that is XWU, angle XWU is equal to angle XUW. So first, let us just denotate what we know. We know that this angle, I'll put it in black, this angle here is 90 degrees. We also know that this angle here in red and this angle here in red again is also equal because those are your two base angles of your isosceles, right? The next thing we know is that, let me just put this, the next thing we know is the tangent line TV is perpendicular to line WU. Why I said that? Because anytime you have a tangent line that is touching your circle and it is intersected by either a line that is your diameter or a line that is a radius, it intersects at 90 degrees. So, or perpendicular to. So what I would say is, I'm just going to show it here and put it in yellow this time. This angle here is 90. And this angle here is also 90. This is what we can denote from this image here. So before we even started, we showed that all the things that I have here. So right after, let me just put this, our line Z plus plus angle Z plus angle XUW would be equal to 90 degrees, right? We can see that because remember, this is 90 degrees, right? So they said, using appropriate theorem, state the 3 reasons why the measured angle here is Z. Is 45. Right? So y angle Z is 45. So let's just solve it very quickly and then we'll put the 3 reasons. Now, if we know that this angle here, so the first reason would be what I wrote there. WU is your diameter, and the triangle, the line, and the angle opposite the diameter in a triangle is 90. Alright, that is the first thing. So what we are saying, right, the next thing we would be saying, so that's the first thing, this is 90. Your next reasoning would be that, hold on. Your next reasoning would be triangle. I want to see the triangle. Right, so triangle WXU is equal to 180. It is also a isosceles, right? Hence, angle XWU is equal to XUW. Alright, we said that. We already know an angle. Right. We already know that the angle, one of the angles, is 90. So what we're saying is our triangle, or 180, is equals to 90 plus XWU plus XUW. Right, so we're gonna say let x be equal to, let's not use x, let y be equal to x right. So if I'm saying y is equal to angle XWU, which is also equal to angle XUW, we can say now that 180 is equals to 90 plus y plus an xy. So that would be, so this implies right that 180 is equals to 90 plus 2y. Alright, so we have 2y would be equals to 180 minus 90. So I'm just gonna put the next part here because I'm running out of space. 2y would be equals to 90, so y is equal to 90 over 2. So y is equals to 45. And that would be your answer for this question right here. Well, not answer, but that is how you would find the red angles, which is 45 and 45. That's your second step. Right, now your third reasoning. Let's make this a little bit smaller. Alright, so we're seeing it. Now let's get the next the third reasoning is right, tangent line TV is perpendicular to line WU. So we said that x plus angle x z plus angle XUW is equals to 90. So z plus XUW is 45 is equals to 90. So z would be equals to 90 minus 45. Z is also equals to 45. That would be your third reasoning. Right, and that is how you would do this question. Let's immediately go to the second question here. The diagram below shows a circle with diameter KF. So they told you KF is a diameter. Line EFG. EFG is a tangent to the circle at point F. Points FHX and FH, K and J line the circumference. Alright. By each of the following steps you're going to work. So again, before you do this, what can we deduce from this image? We can say that I'm going to do the tangents first. XF is perpendicular to EF. Alright, then we can also say that a triangle is 180. Next thing you're going to be putting is we have chord FH, right? There's two triangles that is on that we have two triangles on FH that is at the circumference. Right, so we have this triangle here and then this triangle here. So chord FH produces two triangles at the circumference. Hence, those two angles at the circumference are equal, i.e. FJH and angle FKH are equal. Right? Then okay, so there is another rule. When we're going through it, we'll see it, right? By showing each step in your working where appropriate, find the value of each of the following angles. Angle X. So as I said, this here right, we're saying angle X and angle X and 56, right? So we can say that FJH is equals to 56, right? So we can see that angle FKH is also equals to X, right? Hence, because of that reasoning, X is equals to 56. Reasoning being that these two triangles are on the same chord and they are at the circumference, J and K. The angles are at the circumference, hence they are equal. That is their reasoning for this. angle y. Now if we found out this angle here and we want y, we can clearly see there's a straight line. A straight line is how many degrees? 180 degrees. Right, so let me just write it so that you guys can see. Right, so this here is 56. So we know this is 19, we know this is 56, and we want to find this angle here. Now if we add this angle on top here with y, that should give you 180 degrees. Alright, so I'll type it down. Let's call that, I'll just give that angle a name. Alright, let's call it z. So we can see that angles z and y are supplementary. Why? Because it's on a straight line. Alright, z plus y is equals to 180. Right, so to calculate for angle z, we know z plus 19 plus 56 is equals to 180. Yeah, so that is z plus 105 is equals to 180. So therefore z would be equals to 180 minus 105. So z is equals to 75. Alright, now that we found out z is equals to 7, sorry. Right. Right, z is equals to 75. Now we know, sorry, 19 plus 56 is actually equals to 75, okay? So z plus 75 is 180, so z would be equals to 180 minus 75, which is 105, right? So z is equals to 105. Now we know, I wrote this down here, that is 105 plus y is equals to 180. So y would be equals to 180 minus 105. So y is equals to 75. Alright, and that is how you would do this. Or you can use, say, look at it like this, where this angle here, y, is your external angle, and your external angle is the sum of your vertically opposite angles. So that's x and 19. Right, so y would be the sum of x and 19, and that would be your answer if you want to use it that way. Alright, and that's how you would do this. Let's look at this question here. The diagram below shows 4 points, P, Q, R, and S on level ground. P, Q, R, S on level ground. Alright, where pillars will be placed to mark the outline of a foundation. Their vertical posts are T at R, so you're going to have a vertical post at R. Alright, so you're going to draw a line going up from R. Right. Yeah. From Q, the angle of elevation. From Q, the angle of elevation. So from Q, you're looking to the top of T. So you're going to join Q here. Right, this looks a little bit, because it didn't exactly tell us how big this was. Right, we know that the angle of elevation from Q, so at Q, that means this angle here is equals to 21. 21 degrees. We know that this here, they told you that QRS is flat on the ground. So although it's not seeming like that, it's actually like this. You draw a T and then you're going to be looking at like this. This is how it looks, right? So this is R, this is Q, and this is T. Right, and this angle here is 21. So if it is flat on the ground and we have a pole going up, that is 90 degrees. All right, now if they told you this is your angle, so this is 90 degrees here, although it does not look like that, right? This is actually this image here for you to see. All right, we know that the hypotenuse would be this, right? This here is my opposite, that is the side opposite the angle given, and this here is my adjacent. All right, so let's see. There's a vertical, well, we already did this. Find the height of the post. That is, we find the height of this line. So your RT is equal to your height. Angle is equals to 21. And then we have your adjacent. Your adjacent is QR, which is also 153 meters. So because we have a 90 degrees, let's just put it here, 153, we can say that height, which is your opposite, sorry, no, they want the opposite. All right, this is also equal to your opposite. So you want a because it's 90 degrees, we're going to use so ka toa. Alright, we're looking for something that has adjacent as well as opposite. That would be not sine, because that has hypotenuse, not cos, so it will be tan. So we know that tan theta is equals to opposite over adjacent. Alright, so theta is 21, so tan 21 is equals to opposite, or your height slash height, over 153. If you want to make that the subject, you carry across 153, divide by, that will turn to the opposite of divide by is multiply by. Alright, so we have our opposite, or RT, or your height, whatever you want to call it, is 153 tan 21. So that would be equals to 58.7 meters. And that is how you would get your answer for this question. Part 2, given that the length of QS, let's see, QS, that's this length here. Okay, so let's do it. I just brought the image here so that we can see. They said QS is 135. So this here is 125 meters. Calculate the perimeter of the foundation PQRS. Now, to get the perimeter of PQRS, we need PS, right? Now, if we need PS, that means we need to find this side here. This is not a 90 degrees triangle, so immediately it's either use cosine rule or sine rule. There are no two angles here in this question, so it will be cosine rule that you'll be using to find PS first. Alright, so first off, what is the side that is opposite 29? That is PS. So we know that the side that is opposite the angle given is what everything, the whole formula is equal to. So it would be P S squared is equal to the other side squared, which is PQ squared plus QS squared minus 2PQ QS cos 29, whatever angle. So we don't know what is PS, so PS squared would be equal to PQ, which is 83 squared, plus 155 squared is minus 2 by 83 by 135 cos 29. Alright, when you put this in your calculator, you'll get PS squared equals to 5514. Alright, but you don't want PS squared, you want PS. So PS, if you carry across, is squared, turn to the square root of 5514. So PS is equals to 74.3 meters. Now my perimeter would be equals to 74.3 plus 83 plus 153 plus 110. When you add all of this up, you'll get 420.3 meters, and that is how you would do this question. Alright? And that is the end of January 2023 number 9.